Yeah, we have two cameras on the very forward port of Node 2, so right where Dragon's going to be headed following the completion of this manual piloting test.
Dragon SpaceX on Big Loop. C2V2 link reconfiguration is complete. The soft capture ring extension is also complete.
Dragon copies on the Big Loop. Good ring extension and C2V2 reconfig.
So those comms on the Big Loop, the core, the crew operations and resources engineer here at SpaceX letting the crew know that we have a good TDRS link again. Good C2V2 link again. It's common communications for visiting vehicles. And we actually heard a little bit earlier as well comms to Chris Cassidy to monitor this manual piloting test.
Dragon SpaceX on Big Loop, you are go to execute the proximity manual flight test per procedure 4.041, and I have the target fuel levels when you are ready to copy.
Copy or go for 4.041, and we're ready to copy the fuel constraints.
Your 1/3 fuel usage will be 60.9, 2/3 58.9, and terminate 57.9.
We copy 60.9, 58.9, and 57.9. We'll pick up in 4.041.
Good copy, and we're with you.
All right, so they're going to start maneuvering Dragon, again, making some translational maneuvers. We did get some insight that it looks like they're a little bit to the left of the docking axis right now. And so we should expect them to move directly into the center line as one of their first maneuvers. That's going to be their very first maneuver. And then they have a strict list of choreographed steps just to test out moving on the other axes. And we heard the core Anna Menon calling up the expected fuel usage inside Dragon. They're going to be keeping a close eye on that just to make sure they're not overusing the propellant in those flight tests, making sure we still have good margins for all of the approach maneuvers, and then obviously for everything at the end of the mission itself.
Yeah, and the thrusters that we're using here.
Dragon, on the Big Loop, we are commencing with docking axis capture.
We are following along with you.
So the thrusters that we expect to see firing here would be on the service section or on the trunk. And you'll see some plumes coming out from the shot on your screen.
First part of this maneuver is just to really line them up perfectly with that docking axis. So they were already several meters off once this hold occurred, and so they're making very low impulse commands being sent to those Draco thrusters. Again, as Shiva was saying, there's the 12 around the lower part of the Dragon capsule that they're going to be using, and we're seeing small bursts now.
Yeah, and they actually have a couple of precision modes where they can put in sort of coarse and fine inputs into the vehicle. That's all stuff that they can control off of those touchscreen displays to get the right amount of impulsive thrust into the vehicle. If you're trying to get a little bit oriented to how the vehicle is positioned, that's the nose cone on the top of your screen. So Bob and Doug would be sitting sort of underneath that nose cone and see the pressurized portion of the capsule, and their seats look up into the displays and also would look towards the side hatch, which is currently sealed underneath on the opposite side of where that nose cone is. Very cool to see those thruster plumes.
Yeah, the Kronos emission control Houston actually opened up the iris a little bit on that camera on the space station so we could see these plumes.
And SpaceX Dragon, we've completed the docking axis capture maneuver. We're going to move on to the YZ translation.
Copy, we're with you.
All right, sounds like they've got themselves lined up exactly on the docking axis, so directly in front of that international docking adapter on Node 2. Now they're going to begin some lateral and axial maneuvers. So again, just putting Dragon now off the docking axis, and to just continue these translational maneuvers. So at this point, we should see them head up to the right and up from this view, as they're just making very small adjustments in the Dragon's positioning in front of the space station right now.
And here comes the translation.
We copy.
Yeah, in the data, it looks like we're seeing the 6 thrusters essentially on the bottom of the spacecraft right now from this view, lighting up. So it's going to begin to move them straight up. And it's difficult to tell, but there is a very slow drift upward right now.
Yeah, it looks like they're going about 0.1 meters a second, if I'm looking at this data correctly. So very slow and steady. And they will probably do a quick correction to stop that upward movement. It's a little surreal seeing Dragon so close to the space station. Less than 18 hours ago, I was on the pad at Launch Complex 39A. Now it's so close to its destination.
And being piloted by humans for the second time already in this mission.
And I would just be too excited. I don't know how Bob and Doug keep this so professional.
It's that test pilot mentality.
Yeah, they both have thousands of hours in aircraft. Both test pilots.
Yeah, both came from military test pilot backgrounds. Bob Bank in the Air Force, Doug Hurley, a Marine Corps aviator.
And then I believe Naval Test Pilot School, so... A little bit overexposed there, but you can still see the thrusters firing.
Yeah, our Kronos working to do that deliberately for us so we can see those thruster plumes from this camera view. We're at a normal exposure, so not able to see those jets into the darkness of space. But when we do overexpose a little bit, you're able to see those thruster plumes coming out of the Dragon spacecraft.
Yeah, it's amazing how the plume has to catch the light just the right way for us to even see that it's happening outside of data. Yeah, and looking at the data now, it looks like we have zeroed out that radial velocity delta. So Bob and Doug cleared out that small translation test that they did. We may get a radio call down here that they've completed the Y direction testing. Now, I know we've mentioned this a few times, but it looks like the spacecraft are totally still right now, and that's partially true. They're still relative to each other. But right now, both the space station and Dragon are going around the world, what is it, about once every 90-ish minutes?
Yep.
Or less?
Once every 90 minutes, seeing 16 sunrises and sunsets every single day. And while our view right now...
We've completed the Z translation, moving on to the Y.
We copy, we're with you.
I copy. So I was a little bit mistaken. They just finished up the Z direction, doing the Y next.
Dragon, SpaceX on Big Loop, you have used approximately 1/3 of your prop test budget.
And Dragon copies 1/3 of the prop test budget.
So the Corps letting the crew know how much prop they've worked through. Still have 2/3 of their budget left to do test maneuvers. And of course, any bit of propellant that they're using is just a little bit less margin if they needed to use it for something else. But a good way to exercise the system, see that manual piloting works as intended, and I'm sure for them to have a chance to provide some feedback on how manual piloting actually felt in space and how the control felt.
Yeah, a big part of their job for this mission is really to not only put the vehicle through its paces, but to take a lot of detailed notes and mental notes that they're going to be passing along to any future crew members flying on board Crew Dragon. As we've talked about, the simulators have been a pretty good guide for how the actual manual piloting goes, but things like the ascent up to orbit were quite a bit different from what they expected. And so they're just taking all of that in, internalizing it, and a big part of their job once they come home is to pass that along to all of our upcoming crews, one of which is targeted to launch just about a month after they come home. That Crew 1 outfit of 3 NASA astronauts, Victor Glover, Mike Hopkins, and Shannon Walker, and a Japanese astronaut, Soichi Noguchi, will be aiming to do that flight a little bit later this year. So going through the paces right now, looking at our data, I think I made the same mistake you did, where I assumed them going up would be the y-axis. It looks like that was actually their z-axis, and the y now them moving to the right. So we're seeing some small shifts. They're continuing to use up a little bit of their prompt budget. We heard they're already a little past 1/3.
Yeah, it's actually something interesting about both aircraft and rockets. When you consider the coordinate system, what we refer to as the x-axis is usually the one that goes through the nose. So in the case of Falcon 9 and Dragon sitting on top of each other, the x-axis would have been pointing through the nose cone going up. That's can be a little bit counterintuitive. And then actually in aircraft, the z-axis usually points down, depending on whether you use European or American coordinate systems and the type of aircraft you're working on. But important for both Space Station and Dragon to be on the same coordinate system as they do this eventually as they step into the approach maneuvers here towards waypoint 2. Dragon will be using its relative navigation sensors, again, for relative position to the station, to make sure that it's on the approach, within the bounds of the approach corridor going towards the station when we get to that after this manual piloting test.
Should be getting to that shortly. This manual piloting test was slated to last about 25 minutes. As we have been running ahead of schedule today with all of Dragon's maneuvers, we could be looking at a docking only about 25 or 30 minutes from now. So once they're done with this manual flight test, they'll turn control back over to Dragon's flight computers, and they'll resume their approach, which had actually already started automatically before the crew issued a hold command to the vehicle. And then they'll press in to arrive at waypoint number 2, at which point the teams will do a final go, no-go for docking. They'll depart that 20-meter hold point, and it should be just about 5 minutes following that departure until we get contact and captured.
Yeah, and the crew right now are seated in Dragon in the pilot and commander's seat. Both of them are suited for what are relatively dynamic maneuvers, and they'll continue to be suited until we have confirmation of good hard capture on the space station. So right now, just interfacing with the touchscreen displays, testing out manual piloting. Hopefully secretly a little bit giddy to be piloting a spacecraft.
I mean, before they had launched, Bob Behnken had referred to this mission as every astronaut's dream, getting to launch in a new spacecraft, putting it through its paces. He and Doug Hurley, with those test pilot backgrounds, testing out a new spacecraft has to be as good as it gets. But they're still stepping through this manual piloting. We should have just a few more minutes until they're done with this Y-axis translation. And then they'll be able to turn command back over to Dragon, which will return itself to the docking axis and then begin that approach into waypoint 2.
Yeah, and as a look ahead, so when we do transition into that approach, Dragon will autonomously go towards waypoint 2, which is just 20 meters away from the forward international docking adapter on node 2. And it'll hold there. That'll give the ground team some time, both in Houston and here in Hawthorne, to do a go-no-go poll, make sure that the vehicle still looks healthy, make sure that everyone on board the space station and of course on board Dragon.
SpaceX Dragon, we've completed with the translation maneuvers. We're going to pick up with the closure maneuver.
We copy. We're following along with you.
All right, sounds like they're done with their translations. They're going to start moving it back to the docking axis, put us right back on the center line, and then we're going to resume that approach into station.
Dragon SpaceX, you have used 2/3 of your prop test budget.
I can copy 2/3 of the budget.
Any handling qualities evaluation of the proximity piloting possible?
We've completed the gain setting adjustment for seat 1, and I'll turn it over to Doug for the handling qualities quick look. SpaceX Dragon on the big loop for the handling qualities. It flew just about like the sim, so my congratulations to the folks in Hawthorne. That flew really well, very crisp. It was a little sloppier and wide, just like we saw in the sim, but all the other axes, as well as closure and opening, were all just as per.
Excellent to hear. Thank you.
That kind of gives you an indication of sort of how the design process works. You know, Bob and Doug have had lots of opportunities to test this out and sim it and give their feedback. And pretty cool to hear that their sim experience was very similar to what they saw actually on orbit. Just, I think you said 170 meters away from station right now?
Yeah, we're just 176, and I imagine as a spacecraft designer, that's exactly what you want to hear, is the way that I trained you in it here on the ground is exactly how it performed once you're there for the real thing. So the second manual piloting test in the books, Bob and Doug putting Dragon through its paces. Now we're time to put it all to where we get to our endpoint. We're ready to get Dragon docked to the International Space Station.
Dragon SpaceX on Big Loop. The ground will be resuming approach shortly. We do plan to hold briefly at waypoint 2, so reminder that crew visors down are not required until the ground is preparing to command the final approach.
SpaceX Dragon, we copy. We'll hold at waypoint 2 for a pause, and then we'll get our visors then once you command.
We copy.
And station, it's Houston on the Big Loop. As you've heard, Endeavour is resuming its approach to waypoint 2. Chris, you can monitor now for step 2. That's step 2 and 1.104 Crew Dragon approach and retreat monitor.
Copy, step 2 will work.
Pretty cool view of the International Space Station from Dragon. This would actually be overlaid, or rather their controls would be overlaid on the displays on top of this view. And we got to see some pretty cool views from behind. Actually, there's a view right there. You can see the station on their displays. Visors up, Doug in the left seat, Bob in the right seat.
Yeah, so at this moment, Dragon is going to be resuming the approach. As we heard them informing the crew, they're going to have that one final hold when they're just 20 meters away. That's going to be at waypoint 2. We're expecting it to be a brief hold while the teams all tag up and do a final go to move in for docking. Getting a great look at the space station itself. The docking port is right in the center of our screen. You can see another spacecraft currently docked to the space station, the Japanese HTV spacecraft currently docked to the Earth-facing port, one of those common berthing mechanisms also on Node 2. So Dragon will be the second vehicle to be docked to the Harmony module.
In front of the International Docking Adapter, there'll be a go, no-go pole. The ground teams have worked hard over the past probably years to come up with a set of what we call flight rules. So those are technical constraints, items that we look for, that if any of those criteria were violated, then we have a rule that we've predetermined, gives us guidance to say whether we could approach or not. So far, our vehicle has been very healthy, but technical ground teams will all do their due diligence to make sure that it's still safe to approach.
Right, and at this moment, that approach is continuing, still moving in at about 0.3 of a meter per second. Dragon's coming up on just 100 meters away from the space station.
So the very top there is the nose cone on the spacecraft, where we've got a cool view. Left side of your screen is the International Space Station. Right side of your screen is Dragon.
We're inside 100 meters, continuing to close. Again, we're going to have a short hold at 20 meters. Teams will just do a final check, and then they'll give Dragon the go. We're expecting it to be pretty brief. We should get to that hold point in just about 4 minutes, moving at our current pace.
I think you can see a meatball and an American flag on that on the spacecraft. The NASA logo, of course, referred to as the meatball. I think there was some spirited discussion about the meatball versus the worm during ascent. And those are, you can see those logos. That structure on the fairing structure is actually what the Super Dracos are housed in. Of course, all of those are deactivated now, only used for launch escape during the ascent portion. Nose cone right at the top of the vehicle, and you can see sort of the sealing surface. Those four circular slots right underneath the nose cone within that red ring are the forward bulkhead Dracos. That's what we were using while we were conducting all those burns, the 5 burns to get to this point. Right now, we don't have a reason to use those. We'll only be making small attitude corrections with the service section Dracos. And you can see the service section actually pretty clearly here too. There's a black portion and a white portion sort of separated by a fin. The black portion is solar panels, solar cells that'll charge Dragon's batteries. And the bottom side, the white portion, is actually a thermal radiator that's used to keep the spacecraft nice and cool. Of course, the avionics and the cabin, making sure that Bob and Doug are comfortable inside.
Looks like we're getting a shadow cast. We are just 60 meters away, continuing to close in, just about 40 meters to go until we're at that hold point. Should get there in just over 2 minutes. Meanwhile, teams in Hawthorne and in Houston doing their internal go, no go for docking. They're going to get all the teams polled. Once everyone's go, we'll be able to give Dragon the final go ahead for the vehicle to autonomously fly in and dock with the International Space Station. Should be coming up on waypoint 2 arrival in just about 1 minute, 45 seconds. At this point, it'll be 20 meters away from that docking port. The International Docking Adapter number 2 attached to pressurized mating adapter number 2 at the very forward end of the Harmony module.
Right there on the, right around the center, you can see the forward hatch. It's got a window in it. You can see a couple of handles, and there's some features that look sort of bronze-ish. Those are the pedals that we were talking about earlier as part of the soft capture system. So pretty wild, too, to see. We're so close that we're getting shadows from the station on Dragon. Wow.
And we're getting these views of Dragon's approach from 2 cameras that are right next to that docking adapter. And the movement's a little jarring at times. These cameras are being commanded by a person at the Cronus console in Mission Control Houston, and they send some very basic function commands to the camera, which it then executes automatically. And so they're continuing to follow Dragon in, so we do thank them for their diligence to give us these views of this historic moment as we are just less than 30 meters away from docking.
Right above the NASA meatball logo, you can see 3 of the service section Draco thrusters.
That's right, 12 in all, so the 4 of those clusters spread around the vehicle, used for a lot of the attitude control and any small translational maneuvers like we just watched Bob and Doug execute with their second manual flight test.
Yeah, and actually oriented in a way, too, where if you were to lose some of those thrusters, you still have redundancy and control in those axes That's part of the reason why they're sort of at the angles that they are.
All right, so we should be getting to waypoint 2 right now. So it looks like we do have that hold.
Dragon SpaceX on Big Loop. The ground is go for approach 2. We will be enabling the resume shortly. As a reminder, ensure your visors are closed prior to Dragon's departure from the waypoint. And once Dragon is inside, the crew hands-off point, retreat and breakout are not permitted. And for your awareness, we have sunset in a little less than 8.5 minutes.
Dragon copies all on the Big Loop. Go for docking.
So Doug on the spacecraft confirming their go for docking. They're going to put down their visors. Got some instructions there about the crew hands-off point that we had talked about earlier. That's a point where we don't want the crew issuing any commands to the vehicle. It's about just about 2 meters away from the docking adapter. I believe the number is about 1.7 meters.
Station Houston on the Big Loop. Houston and station are now go for docking. Chris, you can monitor per steps 3 and 4. 3 and 4 in 1.104 Crew Dragon approach and retreat monitoring.
Copy steps 3 and 4. Next Dragon on the Big Loop. Our visors are down.
Copy, visors down.
With the crew confirming their visors down, we should see the final approach resume.
Jason, Dragon on the Big Loop. We are inbound from approach 2.
Copy, inbound.
Station copy.
And we're going to be racing that sunset. The approach has resumed. Dragon closing in. We're inside 20 meters. And yeah, that crew hands-off point should come up in about 3 minutes or so. Right before we get that final docking, it comes about 20 seconds prior, or just about 2 meters away from the station still. And that's just the crew not issuing any abort commands. At that point, it would be too late. And so any aborts would be executed automatically by Dragon itself. So we're closing in at less than 1/10 of a meter per second at this point.
You can see the service section Dracos just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work, making sure that the vestibule and the soft capture system is lined up with IDA2. It's the International Docking Adapter. You can see much more clearly there the hinge mechanism for the nose cone. Those 4 black circles are the forward bulkhead Dracos, not to be used at this time. And then, of course, the pedals of the soft capture system. Wow.
Dragon on the Big Loop. We're inside 10 meters. We cannot make out the docking target, but we do see the outline.
We copy and concur, 10 meters.
All right, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. We should be just about 1 minute, 45 seconds away from docking.
There's a center line camera right in that middle, so that you can see where the forward hatch is, and right in the middle of that there's a window and there's a center line camera that is aligned with the center of the vehicle and the center of the docking mechanism. So So that is what the autonomous docking system is using to line up with sort of a crosshatch, cross target on the docking port. Again, the forward docking port on PMA2, or the pressurized mating.
And so they're continuing to follow Dragon in, so we do thank them for their diligence to give us these views of this historic moment as we are just less than 30 meters away from docking.
Right above the NASA meatball logo, you can see three of the service section Draco thrusters.
That's right, 12 in all. So the 4 of those clusters spread around the vehicle, used for a lot of the attitude control and any small translational maneuvers like we just watched Bob and Doug execute with their second manual flight test.
Yeah, and actually oriented in a way too where if you were to lose some of those thrusters, you still have redundancy and control in those axes. That's part of the reason why they're sort of at the angles that they are.
All right, so we should be getting to waypoint 2 right now. So it looks like we do have that hold.
Dragon SpaceX on Big Loop. The ground is go for approach 2. We will be enabling the resume shortly. As a reminder, ensure your visors are closed prior to Dragon's departure from the waypoint. And once Dragon is inside the crew hands-off point, retreat and breakout are not permitted. And for your awareness, we have sunset in a little less than 8.5 minutes.
Dragon copies all on the Big Loop. Go for docking.
So Doug on the spacecraft confirming their go for docking. They're going to put down their visors. Got some instructions there about the crew hands-off point that we had talked about earlier. That's a point where we don't want the crew issuing any commands to the vehicle. It's about just about 2 meters away from the docking adapter. I believe the number is about 1.7 meters.
Station Houston on the Big Loop. Houston and station are now go for docking. Chris, you can monitor per steps 3 and 4. 3 and 4 in 1.104 Crew Dragon approach and retreat monitoring.
Copy steps 3 and 4. Next Dragon on the Big Loop. Our visors are down.
Copy, visors down.
With the crew confirming their visors down, we should see the final approach resume.
Station Dragon on the Big Loop. We are inbound from approach 2.
Copy, inbound.
Station copy.
And we're going to be racing that sunset. The approach has resumed. Dragon closing in. We're inside 20 meters. And yeah, that crew hands-off point should come up in about 3 minutes or so, right before we get that final docking. It comes about 20 seconds prior, or just about 2 meters away from the station still. And that's just the crew not issuing any abort commands. At that point, it would be too late. And so any aborts would be executed automatically by Dragon itself. So we're closing in at less than 1/10 of a meter per second at this point.
You can see the service section Dracos just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work, making sure that the vestibule and the soft capture system is lined up with IDA2. It's the international docking adapter. You can see much more clearly there the hinge mechanism for the nose cone. Those four black circles are the forward bulkhead Dracos, not to be used at this time. And then, of course, the pedals of the soft capture system. Wow.
Dragon on the big loop. We're inside 10 meters. We cannot make out the docking target, but we do see the outline.
We copy and concur, 10 meters.
All right, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. We should be just about 1 minute, 45 seconds away from docking.
There is a center line camera right in that middle, so that you can see where the forward hatch is, and right in the middle of that there's a window, and there's a center line camera that is aligned with the center of the vehicle and the center of the docking mechanism. So that is what the autonomous docking system is using to line up with sort of a cross-hatch, cross-target on the docking port. Again, the forward docking port on PMA2, or the pressurized mating adapter.
And we are just 5 meters away. Again, we're racing that sunset. This Dragon continues to close, 4 meters to go.
Those shadows of the space station on the vehicle. Yeah, you can actually see the centerline camera pretty clearly there, sort of with the contrast of the sun right now.
3 meters to go. Two meters. We are inside the hands-off point, the chop, the crew hands-off point. 1 meter to go.